All right. Welcome to SIG Cluster Lifecycle deep dive session. I know we are last for today and last for a conference, so bear with us for last half an hour. We will try to fit in our time slot. So let me first to introduce ourselves. I'm Alexander Kanevskiy. I work as a cloud architect in Intel Open Source Technology Center. We are contributing in different parts of Kubernetes, like SIG node, resource management, network, and so on. And my heart is actually closer to SIG cluster lifecycle. That's one of the reasons why I'm here today and talking about it.
And this is Duxu from China, and I have been with Kubernetes for more than 2 years. Now I am a top 50 code contributor to the Kubernetes main repo. Now I'm working on the financial as a software developer. The DXU is my GitHub handler and also my Slack ID. So if you got any questions, feel free to ping me on Slack or CC me on GitHub.
All right. So SIG cluster lifecycle. Our mission is actually to create and maintain documentation and set of tools which simplifies the creation, update, maintenance, downgrades, teardowns of Kubernetes clusters. So what it means in reality? In reality, it means like dozen or even more projects what is part under the umbrella of SIG cluster lifecycle. Today we have only half an hour, so we are not able to go through all of those, and it's deep dive session. So we selected just two things which we want to talk in more details. So we will be talking about the kubeadm, about the best practices, and how it works, and plans for near future, and about cluster API. Again, we cannot go deep, so we will just say how it works, and maybe if you have additional questions, we will take it afterwards. So kubeadm best practices. We are constantly working on improving the user experiences. How you get the kubeadm, how you install cluster, and when some things are changing from time to time. So, and of course, like every environment, every setup, it has its own small differences and so on. So what we have? We have kubeadm, which is packaged as Debian and RPM packages. It's available from our repositories. The thing is, the world is not ideal. So you have different distributions. You might have problems with accessing our repositories. You might have different policies. How do you want to upgrade or stay on a particular version of the packages in your setup? So the packages what we provide might not be the best solution always in your particular setup. But in reality, what you need on your node, you need to have just few binaries. You need to have kubeadm itself, you need kubelet, kubectl, you need to have reference network plugins, and you need to have a CRI tool to interact with runtime. So if for some reason your distribution is not supported, or you have set up where you need to have like some more manual tweaks, my recommendation would be like follow the instructions which we have in kubeadm documentation for container Linux. It will describe like practically like 10-15 shell commands, which binaries in which location you need to put, and you will get the existing setup without packages. Second part is actually fine-tuning. So you installed the binaries. What's next? In previous version of kubeadm, it was saying like we have systemd drop-in config file which describes all the parameters how we run kubelet, and this set of parameters was quite long. This experience has been improved in past 6 months. So don't edit anymore this file. Don't put your additional systemd drop-in files. Instead, we have So like our normal kubeadm systemd file, it actually reads on Debian system etc default kubelet, or in RPM system etc sysconfig kubelet. It looks for variable for kubelet extra args. So if you need to modify some of the flags, this is your location where you should put it. Another part which is also improved in latest versions, it was about to have config map in kube system namespace, which contains like the cluster global configuration parameters. So again, once you init the cluster, and if you later on want to adjust, you can edit this config map, and newly added nodes will be reusing it. So how it works behind the scenes? Actually, the kubelet, the kubeadm is able to detect some of the parameters which is needed for kubelet. It fetches the kubeconfig from this namespace. It merges the information from this etc default files, and then creates two system files which like kubeadm is maintaining. Like one is command line parameters, and one is kubelet dynamic component config. So what's next? Offline installation. This is also something what has been improved in past couple of release cycles. Previously, we had practically two pieces or two parts of the code which was dependent on the network operations. One was flag of kubeadm, which resolves the symbolic label like latest 1.12 to actual release like 1.12.2. It used both in init command and in upgrade commands. Nowadays, we have a bit better code which actually understands what. Like, if for some reason we cannot reach the download servers, like because of firewall issues, because of something else, the kubeadm has good fallback defaults, what you still get the appropriate stable version of your cluster. Second piece, which was doing the network operation, was actually to fetch the images from registry, like the Kubernetes components, and then a couple of infrastructure containers like POS, etcd, and add-ons like core DNS. So nowadays we have additional two commands. One command, config images list, it will allow you to see which images is needed for your particular configuration. And actually, it will show also which version of those images is needed. And second command, it allows you to pull those images. So if you have, for example, like air-gapped install, how you can use it? You can have like separate machine which have direct access to internet. You pull those images where when you do like Docker export those images, transfer the files in your secure environment, and when Docker import those images into your, well, either your host or your private registry. And this is just helpers how to do it. Beside that, all the things what I mentioned, like the kubeadm binaries, kubelet binaries, and so on, all of those binaries are available as a files in our download server. And URL schema is always simple, so you have like releases, name of release, and then like architecture and so on. So usually you can get all the binaries. If you don't know what is actually behind this URL, you can use the Google Cloud utilities to actually list this storage. I know it's a problem here in China, but most probably you know how to get that information. Next thing, again, network problems. So, as I mentioned, Vault is not ideal, right? Most of like old-fashioned IT companies, they prefer to separate networks. So you have probably like internal network where you have all the needed connectivity, but if you try to go to outside Vault, you either don't have connectivity at all, or you have, in best case scenario, the proxy. So how to tell the Kubernetes to use particular proxies? You need to have it's specified in two places. One place is your container runtime. So the container runtime like Docker or CRIO should be able to fetch images. So the first underwater stone here is the no proxy variable. You need to make sure what if you have local registry, so it should go not through a proxy, because otherwise, like public will be working, internal not be working. It's a bit more complex for cluster itself. So here in no proxy variable, you need to take care a bit more. So you need to have like your local domain, like mycompany.com. You need to have ranges for this particular network segment. When you need to have ranges which will be used within the cluster. And if you have a cluster domain, also needs to be specified. So too long, don't read. This is for example, like local network, local domain, cluster segment, cluster domain. Next thing, kubeadm handles preparation for practically all the configuration parameters for you when you initialize in the cluster. But in some scenarios, you would like to use your external PKI to prepare the certificates for your cluster. kubeadm nowadays allows that. The only thing is what kubeadm expecting those certificates to be named specifically. So you can look at the face command generate certs, so to see like which certificates should be named as which file. And then get your private PKI, export the certificates, put it into the directory, and then just instruct the kubeadm to this directory. Next thing, also change in the user experience of kubeadm. So over the time when we developed the kubeadm, we realized two things. One thing is what the Kubernetes itself actively developed. So some flags are changed, some parameters are changed, things going in and out. Second thing is what if it start to add more and more parameters configurable by kubeadm, we simply end up with, I don't know, like 1,000-character long command line to kubeadm. So we cannot add more things into the flags. So it resulted as an idea of ComponentConfig. So you can provide to kubeadm the file, the YAML file, which contains one or more objects, like similar semantics like anything else in Kubernetes. It's versioned, so even though between different versions it will be some changes of how particular flag or variable is named, we have ability to actually migrate between versions of those configs without actually asking user to be changing that. And the current config spec, it was alpha in 1.12, but for 1.13 we are trying to get it into a beta stage. So what kind of configs is that? It's init configuration, it's cluster global configuration, it's global kubelet parameters, and it's JoinConfig parameters. Where were used? I will show a bit later, but what you need to know is actually what global configuration will be saved in your cluster in kube system namespace, and like the config which was used to create the cluster will be stored in the config map kubeadm config, and global kubelet configuration will be saved as the versioned config map kubelet config, for example, like 1.12. So let's look like what those objects are like. So this is an example of init configuration. Here you have like very simple things which you customize when you're initiating the first master. So for example, like the address, what you advertise, maybe some defaults for bootstrap tokens, maybe some CRI socket. And by the way, you don't need to remember those files by heart. We have a helper command, kubeadm config print default, and when you can specify the name of the object, it will print it out the default, so you save it in the YAML file and then just modify or remove the parameters what you don't need to modify, and then you use it. Second object is a cluster configuration. As I mentioned, it's global configs. So what is interesting here is the things which really affects the whole cluster. So you can specify which version you want. Specifically for China, you can specify what my images are actually in my local registry, your network, and then for each control plane component, like for scheduler, for API server, and so on, you have ability to add either additional command line parameters, or you can mount additional volumes if you need to make some custom files available to those ports with those control plane components. The kubelet, again, global configuration. So for example, if you want to enable, let's say, the CPU manager feature globally in the cluster, you can just define it in kubelet configuration, and then every node which joins will be having that configuration enabled. Join configuration. It's used during the join command. Why it's useful? It's usable from few perspectives. So if you have a custom CRI, so you can specify the CRI socket, you can override the names, you can pass additional extra flags to kubelet specific to that particular node. Again, if you have some specifics to be handled on the node. Right. So what's next? Yes, last but not least. In the latest versions of kubeadm, we are deploying the KubeletConfiguration, KubeProxy as a daemon set. So we'll also be able to provide the config, like ComponentConfig for that component. So you can specify, like, if you have like usage of IPVS or some defaults, what you want to adjust for IP tables. Next thing, add-ons. If you know what kubeadm is, you will probably already know what we are handling only the things which is really mandatory for certification of Kubernetes installation. So we deploy practically two add-ons. One is DNS, and we have ability to specify which one. So previously it was kubeDNS, nowadays by default it's core DNS, but if for some reason you have reasons to deploy it otherwise, you have a config options which you can switch on. So everything else, it's up to you. Dashboards, specific networking, kubeadm doesn't touch it. However, as a scope of the whole cluster lifecycle, we are thinking about how to streamline and how to generalize usage of add-ons and how we do it. And we are currently looking at the project called Cluster Bundles. This project was contributed by Google Kubernetes team. Not official Google project, it's just like community ones. It looks promising. Let's see how it will go. All right. So that was my part, and now the word to my colleague.
Okay. Thanks, Alex, for showing us so many best practices on using kubeadm. So kubeadm actually is a simple and efficient way to help you spin up a Kubernetes cluster. In fact, many of the popular Kubernetes installers have switched to kubeadm as a default installer, like kubespray, kops, etc., etc. And however, if you are interested in understanding what is going on behind under the covers, the new command, kube alpha phrase come into your screen. So actually, we bring this new feature in 1.8, and the main target for this new feature is to making kubeadm more modular. And this modularity enables everybody to invoke autonomic sub-steps when bootstrapping the cluster. And you can let kubeadm to some parts and fill in your customizations during the bootstrapping. And actually for several subcommands, so you can try the subcommands here. So actually the first list here is just the command. They have several subcommands here, just like a pre-flight. So you can run kubeadm alpha phase pre-flight master to run pre-flight on the master node, and run kubeadm alpha phase pre-flight node to run pre-flight on the node. And there are so many facets here, so you can try it later after the session to try our new feature in 1.12. And for kubelet, this is the most complicated step in kubeadm. So there are lots of there's about 11 steps here. So I will just pick up some steps to illustrate how it's going on behind the screen. So first, we already have the pre-flight here. So the pre-flight here. Actually, the pre-flight will run a series of pre-flight checks on the node. For example, on the master to check whether it is ready for bootstrapping a master or the control plane, such as we will check about the port usage, whether there is a port conflict during bootstrapping the API server, the scheduler, or the control manager. And it will also check whether etcd is running in locally to make sure that the data will be not skipped or deleted during the new static port. And the next step is to configure kubelet. It will write kubelet configs to the disk and try to restart the kubelet. And this is this is the most important part. This is managed by systemd. So the systemd will help restart the kubelet. And the next is to generate all the certificates, because every component, such as API server, scheduler, are using TLS certificates. So this step will help generate all the needed certificates to help bootstrap the control plane. And the next one is to help you generate the kubeconfig. Oh, sorry. And the next one is to generate the kubeconfig files. This file will be needed by the control plane, such as the controller, the scheduler. And the fifth step is the most important part during the kubelet. It will help generate all the static files to the manifest folder, and the kubelet will try to watch that manifest folder to reload and to recreate all the ports that defined in that manifest folder. And later, the kubeadm will try to waiting for the whole control plane to be ready, because the APIs, if the control plane is not working, so the later steps will not go on. So when the control plane is ready, here the control plane includes the API server, the controller manager, and the scheduler. And the kubeadm will try to expect all these three components to be ready. And next, when they are ready, so we can go on. They will try to upload all the kubeadm and the kubelet config to our config map. And this is a new feature in 1.12, right? Yeah. And this config map will store all the configurations that we used during the kubelet step. So don't worry about you will miss any configurations during the step. So you can just restore to any versions that you have configured. The next, and since the control plane is ready, so the next step we need to tend this node as master, because we don't want our master to be schedulable. So this will help add a tend to the node on schedule to prevent other pods will be scheduled onto this node. And the next, this is the most interesting part of kubeadm. So actually, kubeadm will try to generate a bootstrap token to help new clusters, to help new nodes joining onto the cluster. So it will generate a bootstrap token. So the nodes will use this token to join the cluster. And since the community has enforced RBAC to the API server, so we need to set up some RBAC rules into a cluster, including to allow the node to send CSRs to the API server to rotate his or its certificates, right? And the last step is to install some add-ons. This add-ons includes the normally we use DNS, called DNS, so and the kubeproxy to run as a daemon set in the cluster. Actually, if you are running a hybrid, running a cluster with different architecture, so don't worry about the proxy or the daemon set here, because we have used the multi-arc in Docker images to enforce all the nodes can pull out the right Docker image with the right architecture version. So the next part, kubejoin. So when we bootstrap a control plane, so the next step is to join a node to the whole cluster. And the kubejoin is much simpler than the kubeinit. Normally, we have only 3 or 4 steps to join a node to the cluster, but you have so many charts here, you may get completely confused. Actually, we have add a new effect to 1.12, the experimental control plane and average planet later. And for normally join a node to a cluster, there will be 4 steps here. The first step will still be pre-flight checks. We'll run a series of pre-flight checks on the node, and then it will try to fetch the init configuration from the API server to make sure the node can be connected, and then we'll write some pre-flight specific checks based on the configuration we fetched. And the next step is to directly bootstrap the kubelet. So the step is quite clear and very short. So you will see the node will join to the cluster, and we will run the kubectl get nodes on the control plane. You will see that this node is joining the cluster. But we are adding a new fake experimental control plane to the kubeadm join command. Some extra steps will be added here. The first step is to check the cluster if the cluster supports adding such a new control plane to the cluster. So don't worry about you're adding a run node adding a run node as a control plane. So kubeadm will help you to make sure it all works. Yeah. And the next step is to run kubeadm init pre-flight check. So this pre-flight check is mainly you can consider it as kubeadm alpha pre-flight master. So it is running as a control plane, so you can consider it as a master node. The next step generates static pod. So we will generate 4 components here: API server, scheduler, controller manager, and etcd. So when these 4 manifests are generated, 4 pods will be created in the API server. And this one is still the bootstrapping the kubelet. So all the things done. So we need to upload some configurations we have changed during the kubejoin to the API server. So this is the wider step here. And the last one is still to tainting the node as a control plane. So we will add a taint here to mark the node as unschedulable. So this is the upgrading. So when talking about upgrading, we will split into 2 parts. One is about the control plane, the other is about the node. The first is the control plane. So there will be still the pre-flight here, and we will check the cluster whether the cluster is healthy. So if the cluster is not healthy, we will not do any upgrading actions here. So later we will try to get a configuration from the config map here. So you will make your changes or uploading your changes to the API server in this kubeadm config map. So and the kubeadm will help you to try to fetch all the configurations here and try to enforce or version screw policies. Currently, kubeadm doesn't support to upgrading from two minor versions. For example, if you are upgrading your cluster from 1.10 to 1.12, so this is forbidden. So we are only supporting from 1.10 to 1.11. So you need to upgrading cluster step by step. Yeah. And the next step is still the upgrading the static pods, because we started up this control plane pods as static file. So this static file will be regenerated, and the kubelet will try to recreate this pods later. And for the nodes, actually kubeadm won't help you to upgrade the kubelet version, because this is done by your package manager. So if you want to upgrading the kubelet itself, so you need to issue your package manager such as apt or yum to perform the upgrade. But for the kubelet configurations, kubeadm will try to download the config map here. So the kubelet config 1.1.x, where x represents your kubelet version here. So for this feature, we need to we require the kubelet version to be upper than 1.11. So for kubeadm, we have several changes in our 1.12. One is about we are adding component config into our API, which is still considered alpha, but we will try to make it better or higher version in the next release. And the most significant changes here is we are adding a new fake experimental control plane to help you join a new control plane into the cluster. We have also done several improvements during the 1.12, such as the CR support and the offline and the air gap support. And we are going to deprecating server hosting and HA, because we already have this flag here, and this flag will help you to make a high availability. And for the next release, we are going to make kubeadm general availability. So this is what we are trying to do in the next release, and this will be coming true in the next month, the December. And we are also going to promote the component config from the Alpha 3 to Beta 1, so we can have a better version to component config. And we are also going to grade phases to Beta, which is still Alpha now. And there are several bug fixes here. So kubeadm is trying to improve user experience during this 3 or 4 releases. Yeah, so we are trying to make kubeadm a better tool for users to use, and you can rely on kubeadm as a building block for your customizer installer.
All right, so we just have a couple of minutes left, so I'll try to very briefly describe a cluster API, what you need to know. It was a few sessions already here during this KubeCon here, which was talking about cluster API plus Tencent. So the things what you really must know about the cluster API. So first thing, it's declarative. It describes the cluster, machine set, and machine deployment. So to draw analogies, where machine is your pod, machine set, it's replica set, deployment, it's machine deployment. So we have controllers like the common logic, which operates the same thing. So you can create a machine deployment, describe what kind of template of machine it needs to be done, and machine controller will create the machines according to that specification. Logic is common between the providers. Of course, like some of the providers will need to implement the exact specific like plugin and piece which handles like individual machine for particular environment. So for example, like Amazon, VMware, whatever you have, we need to create their own provider. The idea is what like we will get the a declarative API which we can reuse across multiple tools. So like 10 kilometers view how it works. First of all, you need to have some cluster where you deploy CRDs, which I just described. You need to deploy the controllers, which will be talking to your cloud API. And you have a couple of utilities with which you can interact with cluster API. Like one is to bootstrap the things, and one kubectl to do like all normal activities. So once you're done with your local cluster, would it be like your management cluster or like mini cube on your laptop, doesn't really matter. You can copy those objects, those controllers, so you migrate it to a real cluster what you have. And once you are done, what you can do, you can practically like scrap your bootstrap cluster and when you operate normally with your cluster. So you can create more clusters, you can add machines, scale them up and down, up to you. It's all APIs. So the current set of, like the whole cluster API is, we don't have even yet the real like alpha release. So we are preparing to have a formal alpha release. Providers which is implemented right now, like few of them already did small releases, but majority of them is still under heavy development. The actual list you can find on the project page of Cluster API. If you have some specifics for local providers here in China, for example, Tencent, I don't really know where we are publishing their code, so probably you can ask them to share that part. So
don't feel intimidated to make any changes to our repo. So even a small change can make a big difference. So if you got any questions during the participating, so you can just ping me on Slack or send me on GitHub, and we will try to help you get started with our SIG. So thanks for all your coming, and we hope everyone can help us to make it better. Thanks so much for today.
Yeah. So what now? We really want your contributions, like with small bugs, or participation in our channels. Like we know it's many of them, but pick the ones which you really like and which is close to your heart, and get involved. I think we have a couple of minutes for questions if anyone would like to ask.
I know we have already cloud provider to support different cloud providers like AWS or Alibaba. Yeah. So you mentioned here we will use some kind of cloud provider, right? So what's the difference between the cloud cluster provider and the cloud provider? Okay. So it's basically it's based on it, or just?
Excellent question. So there is a difference. So the current cloud provider, it's usually about the integration between the Kubernetes control plane towards services what provider provides, like load balancing, networking, ingress controllers, policies, maybe networking, maybe like persistent storage and so on. Cluster API cloud provider, it implements one simple thing. Well, not so simple actually. So it interacts with provider API to create a new, let's say, virtual machine or physical machine, and when bootstrap the like basic operation system on it, and when get the access, let's say SSH to that machine, and when this piece actually will go and execute on that newly provisioned machine, the kubeadm.
So there are different systems, and they will develop independently.
Different purpose. So the Cluster API cloud provider responsible to create, delete, and bootstrap the new machine.
Thank you.
The question is?
You mentioned the feature flag experimental control plane, right? So can we use that for initialize a cluster with multiple nodes, multiple master nodes, I mean?
Yes, we can.
Okay, so what about the certificate? You didn't mention that. It will handle the certificate from the first master to the others?
I'll explain because of microphone. So, yes, we have documentation how to do it. We have, well, when you're creating nodes using experimental master join, you need to copy a few files from your first master to any nodes.
Okay. So
and when you're executing like kubeadm join experimental and so on, it will pick up those files and then handle whatever.
okay, I see. So there are some menu steps to transfer the certificate files between nodes,
yes,
master nodes, yeah?
Yes, and actually if you go to kubernetes.io/doc/kubeadm install, there is a special section which says like how to use that feature. And we have like really, I don't know, like 5-6 lines of shell snippets, which you just copy paste and it will work.
Okay, thanks.
Pass.
Hi, you mentioned the bootstrapping and like needing maybe another cluster to bootstrap your first cluster. What is there in terms of like disaster recovery? Maybe you've destroyed that bootstrapping cluster and your main cluster has a problem.
Well, why you need to have existing cluster is because the whole object definitions is CRDs. So you need to put them somewhere. And when, like the API storage, and when controllers, like cluster controller, machine controller, they need to be run somewhere. You can run them as a standalone binaries, so, but still you need API server where you store the whole objects. For disaster recovery, of course you can have like your management cluster and like permanently hosting those components, but it's just objects in database. You can have as many copies as you want, just no matter what, like, don't create the race conditions for the multiple controllers try to do the same thing using the cluster, cloud API.
Okay, so best practice is to probably keep that sort of bootstrap cluster around.
Or create the proper like management cluster.
Yeah.
So you have like management cluster as a cloud provider or infrastructure provider, and when for customers you just provision the clusters. This is something, for example, what Tencent was showing 1 hour ago on their presentation.
Okay, thanks.
I think we are done. We ran out of time. So thank you very much for visiting our session.